back to Mrs. Riley's Maths videos, and today what we're looking at, you can see here we're talking about rounding, about significant figures, and then later on about decimal places. So I'm just going to recap. I'm going to go over again what we did in class today with first year, but other people may be watching this later on and you may not have seen this, so I'll just talk you through this. So we've talked about estimates before and we've talked about rounding numbers, and usually what happens when we round is we make something that's very accurate less accurate. Okay, and we do that because it's easier to use the less accurate number because there's fewer numbers in it, or because there's less decimal places in it, and it just makes it an easier number when we're not using a calculator, an easier number to use in different types of operations. So the number I'm looking at today is this number, 181,126, and what we're going to talk about is how we're going to round that. Now, we talked previously about rounding to the nearest 10, where 181,126, we'd round to the nearest 10, so we got rid of that last number because it's a units and these are the tens, and we got rid of the 6. And remember, if it's 5, 6, 7 or 8, it increases the number that is next to it. Okay, and if it's 1, 2, 3 or 4, that number stays the same. So we're looking at, is it 5, 6, 7 or 8? Is that the number that we're losing, 5, 6, 7 or 8? If it is, it increases the number next to it. If it's 1, 2, 3 or 4, it stays the same. So here we have 181,126. We're losing the 6. Now that's one of this group, so it's going to knock this number up by 1. Rounding 26 to the nearest 10 rounds it to 30. So what we're left with is 181,130. And the nearest 100, we lost the 2 and the 6. Rounding all of that to the nearest 100 is 100. So this 1 stays the same because the 2 is in this group of figures here. Okay, nearest 1,000, it's these 3 digits we're looking at. If they are less than 500, then it stays the same. This one stays the same. If they were more than 500, this would increase. Or you can say the digit that we're losing, the closest one to the one we're keeping, is a 1, which is 1, 2, 3, 4. So this digit stays the same. So it rounds to the nearest 1,000. It's 181,000. Now we're introducing a new idea today, though you may have heard it before, and that's significant figures. Significant, something significant if it's important, or if it stands out, or if it carries a particular importance or value. Significant figures is sometimes written as SF. So significant figures, SF. So if you see SF somewhere, it's significant figures. Now if you look at these numbers, this number here at present has 6 significant figures. 1, 2, 3, 4, 5, 6. This number here, when I round it to the nearest 10, has 5 significant figures. 1, 2, 3, 4, 5. Now why is the 0 not significant? The 0 is not significant because it's not carrying any particular extra information about the number. It's not making it any more accurate. This was the more accurate version of this number. By giving it to 5 significant figures, we count the 0 as not being significant. And here, when we round it to the nearest 100, we're actually giving it to 1, 2, 3, 4 significant figures. 4 numbers that aren't zeros. Sometimes they're called lead numbers, the numbers that start from the left counting towards the right. 4 significant figures and then 2 zeros. These zeros though are really important because they keep the same value. Make the number keep the same value. So for instance, this number, if this is the amount of money you had in your bank account, 181,126, you wouldn't mind too much it being rounded to 5 significant figures as long as that 0 was on the end. If the 0 wasn't on the end, instead of 181,126, you'd now have 18,113. That's quite a reduction. So that 0 helps it to keep the value. These 2 zeros here, this is 4 significant figures, 1, 2, 3, 4. These 2 zeros here make sure it keeps again its value of around 181,000. These 3 zeros keep the value of 181,000, and yet we only have 1, 2, 3 significant figures. So as you can see, the significant figures count from left to right, and when we lose a number like a 6, or we lose a 26, or we lose 126, we fill in those spaces with zeros. If it was to two significant figures, so this is our original number, 181,126. If it was to two significant figures, we're losing quite a lot of accuracy, aren't we? By writing it to 2, 1 and 8. We're losing this 1. So we're basically writing it to the nearest 10,000, which loses a lot of accuracy. So that's significant figures, and I'll work through the worksheet in a moment. Now, decimal places is a little bit similar to that, but first of all, let's talk about decimals and significant figures. 13.4729 meters has 1, 2, 3, 4, 5, 6 significant figures at the minute. 6 sig figs. Okay? If I lose that 9, then it's going to go to 1, 2, 3, 4, 5 significant figures. But remember, if I lose that 9, then the 2 increases by 1. Okay, so it's going to be 13.473 to 5 significant figures. 4 significant figures, this was my original number, 13.4729. I'm losing both of those now. Again, the 2 is less than 5, 29 is less than 50, whichever way you like to look at it. I'm losing those two. 13.47, that's 4 significant figures. Why don't I need zeros here? Why don't I have a 0 here and a 0 here? Well, I guess because after the decimal point, number zeros at the end don't carry any extra value. I could go on forever otherwise drawing zeros and be here until tomorrow just adding in an infinite number of zeros, and it wouldn't change the value of that number at all. 4 significant figures. 1, 2, 3, 4. Here, to write it to 3 significant figures, I'm losing the 9, the 2 and the 7. The one closest to the one I'm keeping this 4, 1, 2, 3, 3 significant figures. I'm keeping the 4, but I'm losing the 7 next to it. But it's bigger than 5, so I have to round up. So 13.4729 becomes 13.5. Now that's 3 significant figures. And finally, 2 significant figures. I'm losing the 4, the 7, the 2, the 9, but the 4 is the one to look at. It's less than 5, so 13 is my 2 significant figures. And finally, 1 significant figure. I'm losing everything but this 1. And here I do need to put in a 0 to keep it around the same size, so it's 10 and not 1. Now, you may have been looking down the left-hand side, decimal places. Decimal places are the numbers that we count, the digits that we count after the decimal point. And we'll be doing a lot more work on decimals, and we'll explain what these different places mean. But for now, when you're counting decimal places, you're counting numbers after the decimal point. So 13.472 is written to 3 decimal places. Okay, we lose the 9, so 13.4729, we lose the 9, and to 3 decimal places, that means there's 3 numbers after the decimal point, it's 13.473. Here's the number again, 13.4729. I want to write it to 2 decimal places. I only want 2 numbers after the decimal point. So I'm losing 29. Okay, the 2 here, which is next to the number I'm keeping, the 2 is less than 5, so the 7 stays the same, so it's 13.47. 1 decimal place, I only want to keep this number after the decimal point. The one closest to it that I'm losing is the 7. 7 is bigger than 5, so it rounds 4 up to 5. And finally, so that's 13.5 to 1 whole number, in other words, to no decimal places, that would just be 13, because again the 4 is less than 5, so it doesn't change the 3. Okay, now how does that work out? Let's work through the worksheet from today. This is the red one, this is the easier one, so we'll go with this one because it explains it a bit better, but you can check your answers from the other ones. How many significant figures does each number have? So what we're going to do is we're going to look at these numbers here after the decimal point. Okay, That's got 3 significant figures because there's 3 numbers after the decimal point. Here, when we count significant figures in a decimal, we don't count the 0. As it says here, find the first non-zero digit in your number. That's a 0, that's a 0. This is my first non-digit number, non-zero digit. So after this, 1, 7, 2, and 4 are all significant figures. They're 4. Okay, here, find the first non-zero digit. 1, 2, these are all 0 digits. Here's the first one after the decimal point. I'm going to count that as 1 significant figure. Here, I've got significant, there's a 0, 0.0. Now, I've got 5, 0, but they seem to have chosen this as being 2 significant figures because they've counted that 0. Now I would actually probably just give that, if I was writing that answer, I'd probably put 0.05. They were probably asked to give their answer two significant figures, so they had to add in that 0 to provide the second significant figure. Here again, underlined 2020, starting at 2 because that's the first digit that's not a 0. On the left hand side, 1, 2, 3, 4 significant figures, again probably because like this one they were asked for 4 significant figures. And finally here, starting from the left, that's a 0, don't count it, that's a 0, don't count it, but starting from here, 1, 2, 3, 4, 5, 6 significant figures. The attendance at a World Cup match was 92,847. Round this figure to 4 significant figures. So 4 significant figures, let's write it here, 92847. 4 significant figures, I'm going to have that one, that one, that one, and that one. I'm going to get rid of that one. So it's going to be 928. I'm keeping the 4, but I'm losing the 7. The 7 is bigger than 5, so the 4 is changing up to 5. 92850. To 3 significant figures, 1, 2, 3. I'm keeping the 9 and the 2. The 8 is the last digit I'm keeping. This is a 4, which is less than 5, or this is 47, which is less than 50. So the 8 stays the same. But again, I fill in the 2 zeros so that we know the attendance was around 92,800. So it's a rounding of 92,847. I've got 92,800. 2 significant figures, 1, 2. I'm keeping the 9. I'm keeping the 2, but this 8 is going to round up the 2, so 93,000, and 1 significant figure is going to be just the 9, and the 2 is less than 5, so it's 90000. Round each of the following to 1 significant figure. So they've helped me out here by underlining the figure that I'm going to use. I'm just looking to see whether it changes at all. So this one is going to be 0.08 because I'm losing the 8, so it rounds the 7 up by 1. Here I'm losing the 3. It doesn't change the 9 because it's less than 5. Here 1, 2. I'm keeping the 4. And don't count these zeros, they don't count as significant. I'm keeping the 4, but I'm losing the 7, so that actually goes up to 5. And here I'm losing the 7, so that actually, now this is a bit weird. So I've got 0.00. That 7 rounds that 9 up to 10. So it's 0010, and we'll be talking about that again. And when we come to study decimals, we probably don't even need that 0. 0.001. Round each of the following to 2 significant figures. So I'm keeping the 1 and the 3, but I'm losing the 7. So it's 0.14. I'm keeping the 8 and the 9, but I'm losing the 6. Oh, this is going to be difficult. So the 6 rounds up the 9 to 10, which rounds up the 8 to 9. So it's 0.90. Here, 0.0. I'm keeping the 5 and the 7, but I'm losing that 7. So it's going to be 0.058. Here I'm going to keep 0.00. I'm keeping the 6 and the 0. 6 and the 0, and the 3 doesn't change it. Okay. The number 1628 is 4 significant figures, rounded to 3 significant figures. So to 3 significant figures, I'm losing the 8, the 2 goes up, it's going to be 1630. So two significant figures. I'm losing the 28. It doesn't change the 6 when I lose it because it's less than 50, or the 2 is less than 5, so 1600. Okay, so you can check your answers. If you did the amber sheet or the green sheet, you can check your answers. Okay. Now, round the following numbers to the nearest 10. So 13 will be 10, 23 will be 20, 18 will be 20, 98 will be 100, 134 will be 130, 192 is 190, 370, 1240, 52,050, or sorry, 5,250, and 37,550. Okay, to the nearest 100, 100, 300, 200, 300. Remember, I'm looking here at the 40. The 40 is less than 50, so it's 100. The 60 is more than 50, so it goes up to 300. The 80 is more than 50, it goes up to 200. The 45 is less than 50, it goes down to 300. This one goes up to 400. Sorry, 400. 985 goes up to 1,000. 1,050 comes down to 1,000. 6,929 goes up to 6,900. This one goes to 8,700, and this one 12,425 goes to 12,400. To the nearest 1,000, 2,300 is at 2,000. 1,978 is at 2,000. 4,368 is at 4,000. 6,500 is at 7,000. 9,500 is at 10,000. 13,483 is 13,000. 49,268 is 49,000. 123,436 is 123,000. 15,500 is 16,000. 999,501. Oh no, that's going to round it all up. That 5 is going to round that up to 10, that up to 10, that up to 10. So it's up to 1,000,000. Oh, that was a hard one. 1 decimal place, 4.9. 1 decimal place, 5.0. 1 decimal place, 2.7. 1 decimal place, 7.6. 3.4. 12.1. 18.9. 44.3. 82.4. 49.3. 2 decimal places, 0.27. 1.60. I lose the 5, that rounds that up by 1 to 10, which rounds up the 5. 6.47. 2.57. Oh, this is nasty again. That rounds that up, which rounds that up, which rounds that up. 9.00. 5.72. 0.43. 44.56. 82.36. and 325.17. Only counting, remember, the digits after the decimal point. Okay, hopefully that helps. We'll be going over that again when we go back to decimals. Take care.